Would you want to come up? Okay, we'll make a start. Kia ora koutou, good evening everybody and welcome. Before I start, a couple of health and safety things. If we do need to evacuate, there are doors each side. If you go out through that door or if you're leaving through that door, please remember there are steps. If you need the toilet, it's out of that door, down the ramp, and then you have to walk across to a little room over there, which might be a bit uncomfortable tonight because it's raining, but that's where it is. Before we get along, then we would like to give an announcement about the Waipara River catchment meeting.
So my name's Rima Herber. A lot of you will know my brother Raymond Herber, who has got the Iron Ridge Quarry Sculpture Park up the Waipara River. And my husband John and I are living up there at the moment, and I've got an ecological background and a background in water. And on the 28th of June, I'm running a meeting in the Waipara Hall at 7 o'clock to just gauge interest in starting up a Waipara River catchment group. So anybody who's interested to find out more, do come. It won't be so much of a formal meeting as a meeting to just introduce the idea, gauge interest, and to set up a contact group so people can let me know what their concerns and priorities are around the river, and we'll go from there. Okay?
Okay.
That's the 28th of June at 7 o'clock at the Waipara Hall.
Thank you. Thank you. Now, first of all, apologies for last time. We had to cancel our meeting at short notice at the last time because of a problem that the speaker had. That speaker was Dylan Mugridge from New Zealand Beef and Lamb, and he's rescheduled for September. So anyone wanting to listen to Dylan from Beef and Lamb, he's their environmental manager. We've rescheduled him for September. Our next meeting is going to be about the economic opportunities for hemp with two people who are, I believe, the Brothers Green, Brad Lake and Jamie Engelberg.
Brad.
So they'll be along next time, Thursday, July the 15th, same place, same time. Tonight, we have Dr. Charles Merfield.
Better known as Merf.
Better known as Merf. And he's going to talk about regenerative agriculture, and I think it's probably best that I hand over to him and let him carry on.
Okay, great. Thank you very much. Cheers. Okay, so regenerative agriculture. I'm going to start at the end. I've got a short clip of video here by a farmer, Simon Osborne. So he's one of New Zealand's leading arable farmers. He got into no-till pretty much as soon as no-till came out here, and he's now heavily into regenerative agriculture. Now, the sound on this isn't great because it was taken on a phone in a field in a windy day. So I will go back over what he actually says, but listen carefully, and we have the volume wound right up.
But I'm just out here now, just about to come and put the cover crop in that I see. I think we should take it for grazing again. So I'm having a count up of the species that are here. There's at least a dozen species of plants out here, including the ubiquitous speedwell plant, which is just starting to flower. And this provides, the speedwell flowers provide a really valuable nectar pollen source for bees and other insects.
So, Simon was about to go out and drill a cover crop in, but he sees there's quite a bit of green cover out there and he's thinking he should take it for grazing. But he's doing a plant species count, for starters. And then he discovers there's some speedwell and there's some other weeds out there and they've got some nice flowers on them. And he's been told by the guys up at Lincoln University that they're really valuable pollen and nectar sources. So he's thinking, I might leave it for a month so I can feed the insects. How crazy is that? We're a very, very long way from yield maximisation. So, The mantra of intensive agriculture for the last 80 years, essentially intensive agriculture came out of the post-Second World War period, has been yield maximisation at any cost. That's what the Green Revolution was all about. What we have now is a very substantial amount of science showing the damage that intensive agriculture does to the planetary life support systems. And particularly over the last 20, 30 years, that evidence has been mounting up increasingly strongly. And so what we can see out there now is the drivers and constraints of agriculture are changing really quite quickly. We're seeing that now in New Zealand with legislation around land and water, nutrient management. Climate change controls on farming will be coming in very shortly as well, I have no doubt. So to me, the key thing here is in terms of regen ag, what's the context? What's this change? And so I frame agriculture within these two things. The first is called the 9 planetary boundaries. So this was developed by a set of very bright people at a place called the Stockholm Resilience Centre. In about 20 years, they sat down and they said, right, okay, how does the planet work? What's the key parts of the planet's operating system? And so they came up with this list. For those of you at the back, we've got stuff like climate change, novel entities, stratospheric ozone depletion, ocean acidification, biochemical flows, land system change, and biosphere integrity. And then they said, right, those are the key parts of how the planet works. Those are the key things. They said, which of them are okay, which of them are kind of marginal, and which of them in the doo-doo. So climate change, which gets an awful lot of press, is actually only in the kind of, we're kind of pushing our luck a bit. What's called biosphere integrity is basically biodiversity loss in plain speak, is in the red zone, along with too much phosphorus and nitrogen in the environment. So farming is part of the planetary systems. Farming has to do its bit to bring this stuff that's in the red and the orange back into the green spaces. So that's the kind of the limits of what we can do in agriculture, and we've blown 2 of them completely out of the water, and 1 of them we're in deep doo-doo with. So now in farming, yield is not the only metric. In fact, there are multiple metrics. Agriculture is part of ecology. And about 30 years, a bunch of scientists came up with this concept called ecosystem services, or nature's services they're sometimes called. These are fundamentally the best measure of agricultural outputs. And so there's 25 odd ecosystem services. People vary in what they kind of, different scientists decide what's quite in and quite out. But there's 4 main subdivisions. And the first one is supporting services, and the second one is provisioning services. Provisioning services is where we find the production of food and fibre. So food is an ecosystem service along with fibre. There are other things like producing oxygen for us to breathe. And so I'm looking and thinking there's a few farmers here. Who got paid for the oxygen they produced on their farm last year? Nah, you were robbed. So farming produces a whole load of ecosystem services and doesn't get paid for them. And we don't hear any complaints about that until we stop providing ecosystem services. So another ecosystem service is filtering water, so you get nice clean water in the rivers. And everybody was kind of hunky-dory when that was being done for free, but when it stopped being done and we started getting some nitrogen and phosphorus in the water, everybody kicks up stink. Farmers only get paid for the food bit. There's a massive problem here. They're not getting paid for everything else. If they got paid to purify the water, they'd probably do a much better job of it because there was some kind of incentive in there. So these are the other 2 main divisions, regulating services and cultural services. I find cultural services quite interesting. As a European Pakeha, you go, cultural services of land. Yeah, I guess kind of some of the farmland uplands in Europe's kind of quite pretty, you know, some of those mountain farms with cows with bells round their neck. Yeah, cultural service. You're tangata whenua. We're talking about the whenua. The cultural services are probably the most important component of ecosystems for Māori. So interesting different perspectives looking at this thing and kind of taking away very different messages. So for me, we need to use ecosystem services as the framework of all the things that agriculture produces and then say, okay, how are we going to pay for all of these? And we also need to look at the natural world and go, the natural world produces all those natural forests and stuff, even the pine forest, they all produce ecosystem services. So to me, those are the 2 lenses to look at farming through. The planetary boundaries, that's the operating space we have to stay within, and the ecosystem services are what we produce. So this is very different from the old yield maximisation, complete blinkered focus of intensive agriculture. So I think we are potentially at the start of a fourth agricultural revolution, because we haven't had enough revolutions in agriculture. I think the tide is really starting to change quite dramatically. Okay, and this is where we come into regenerative agriculture. We need an alternative to mainstream agriculture, and there are a lot of what I call these alternative agricultures, the alt ags. You could also call them sustainable agricultures or ecological agricultures. And there's a whole bunch of them here. Some of them that you are close to the front, I'll read them out because this is probably a bit hard for the back. We've got agroecology, conservation agriculture, no-till, organics, biodynamics, agroforestry, permaculture, natural farming and holistic management. You'll have probably heard of some of those, at least organics, it's reasonably famous. Some of the others are probably slightly more obscure. However, these things have been around for a very long time. These four, agroecology, organics, biodynamics and agroforestry actually probably goes back to the start of agriculture. The other three started around the 1920s. So they've been around for over a century now. Intensive agriculture only started in the 1950s. So these alternatives actually predate what we would recognise as intensive agriculture today. The 1920s, a lot of farmers still don't have mechanical power on the farm. It's all horse and cart stuff. And they're not lashing nitrogen fertiliser around because it barely exists. So these alternatives was looking at mainstream agriculture and kind of going, we actually don't like what's going on here already. And that's before we get into the 1950s and tractor sizes start going up from 40 horse to 400 horsepower. And farms go from 50 hectares to 500 hectares. So most of the rest have been around for about half a century. Regen's different. It is kind of the new kid on the block. And it's actually kind of a bit hard to try and work out what regen is and where it started. In terms of the academic literature and kind of all the literature, the first time we found the term being used is back in the late 70s. Now, over in the States, this guy called Bob Rodale, who's the son of the founder of the Rodale Institute, which is the leading organic research and promotional institute in the States promoting organic agriculture. He promoted this term regenerative agriculture back in the 1990s, and it was very clearly linked into organics because Rodale has always been about organics. It peaked in the late 80s and early 90s and it dropped off again. And then in the last few years, it's really, really ramped up. Fortunately, some guys in the Netherlands wrote a paper and they went and did some legwork. And they did a whole load of literature searches, not just to the academic literature, because there's virtually nothing on regen in the academic literature. They went through all the popular press, magazine articles, the whole shooting match. Well, they didn't actually. There's a big database that did it for them. So they did a big database search. So what they did is they searched for the terms regenerative agriculture, regenerative farming, sustainable agriculture, organic farming, organic agriculture, and agroecology. And this is probably going to not show up on this screen, so I'll just wander over here. So these brown bars, that's regenerative agriculture. So you can see it nearly completely died a death around the early 2000s, and literally here it's gone completely bonkers. Just really, really ramped up. These two dotted lines are organics, and it's kind of been more of a kind of steady path. You kind of almost wonder it's actually levelling off over the last 5 years or so. This thick black line peaking up here is interesting. That's sustainable agriculture. And it's kind of this generic term, so I would have thought it kind of would have stayed fairly constant, but it really peaked in the 90s, dropped off, and it seems to be ticking up again. And you might just be able to see ticking along the bottom here is agroecology. Agroecology is a fairly technical term, so it's not used much in public for public consumption. So all of a sudden, regen has kind of come back from the grave. However, there's some complexity here. What Rodale was talking about and what Rodale, the institution, is talking about today in terms of regenerative agriculture, and they're promoting this really hard, is an extension to organic agriculture. They've, in the last few years, decade or so I suppose now, developed this thing called regenerative organic certification. You cannot get that unless you have United States USDA equivalent organic certification. But most regen farmers wouldn't be able to get organic certification. So although it's called regenerative, it's actually something completely different to the regenerative farming that's making the headlines today. I also suspect the regen that was peaking in the 80s and early 90s is actually probably quite a different beast to what we're dealing with today. There's also complexity. A lot of people, when they say they hear about organics or regenerative, they really latch onto the name and start taking the name apart. Got to be really careful. This is Nicole Masters from her website in 2019, and she said regenerative is synonymous with a bunch of other things, including biological agriculture, holistic agriculture, eco-ag, natural intelligence, natural farming, humus/carbon farming. So if you start picking regen apart on the name, you just say, well, it's something else. So it's a fairly muddy little pile here. And regen's actually been a bit of a rebranding of a marketing exercise as well. So in the early 2000s, this thing called carbon farming popped up. The late 90s is when climate change really starts hitting the public headlines. We start getting the first kind of political action going on, which kind of died, unfortunately, after that. And so carbon farming popped up because a bunch of farmers, particularly over in Australia, where they got huge land masses and soils with absolutely stuff full carbon in them, I thought, maybe I can make my fortune farming carbon instead of sheep. Genius. And nothing came to pass. So it kind of died a death. And then somebody said, oh, let's have a rebranding exercise. Let's call ourselves biological farming. Great. So I went to some conferences in the mid-2000s called biological farming conferences. The Association of Biological Farmers was set up. It fired off with a hiss and a roar. And after about 10 years, it ran out of steam. And then somebody said, oh, geez, better have another of those rebranding exercises. So we'll slap a regenerative agriculture label onto it. That seems to be catching on in terms of terminology and stuff. And so off regen farming's gone. It's basically been the same mob of farmers doing carbon farming, then hopped into biological farming and now hopped into regen. So all the usual suspects have been here through all these rebrandings. My question is, of course, well, if we have a rebranding exercise here every 10 years, are we going to have a rebranding into something else in 5 or 10 years' time? So let's try and get into the nub of this. What is modern regen ag? This is really difficult. It's a whole bunch of things. It's a real mixed bag of stuff, and it's still evolving. We're involved in the big Regen Ag white paper. We deliberately refuse to define it because the target is moving so quickly. And if we did define it, all our academic colleagues would jump on the definition, try and rip it to shreds. So we're not that stupid. To me, it's part of this agricultural revolution that's going on. It's also very clearly a groundswell of farmers. And I like to make a comparison with regen and organics, because they seem to be following very similar trajectories. Regen today is kind of where organics was in 1920, a century ago. It's really kind of rather curious. Organics was definitely a groundswell amongst the landed gentry in England and a whole bunch of scientists. There was a bunch of scientists, some actively involved in promoting organics and setting up the associations. Others were kind of key figures whose science was being used and pulled into the organic fold. Regen is entirely driven by farmers. Up to about 2017, there was literally no research on regen at all. Entirely driven by farmers. It's a social movement as much as an agricultural movement. And this has come out very clearly in some research that we have done around regen that I'll talk about later. Regen has also very clearly come out of the American Midwest, those grassland ecosystems. There's typically mixed farming, so lower intensity systems. Unsurprisingly, the Aussies picked it up first because they're in very similar dry ecosystems, extensive grazing, but it is rapidly progressing through the world. It's certainly big in New Zealand now. It's certainly turning up in the UK. I'm not quite sure how much penetration it's getting into Europe and stuff because, of course, there's language barrier issues getting into non-English speaking countries. It is, amongst all things, also a willingness to change and challenge the status quo. So a lot of the regen ag stuff is about rethinking how you're doing farming, have an open mind, question what you're doing. And that really does make it harder to find because it's an awful lot of things all rolled into one. One way, therefore, to actually get your head around what's going on is to get really practical. and go, right, okay, what kind of stuff is being done on the farm? So when I wrote my first Regen Ag paper in 2019, I went out looking for all the information and discovered there's nothing in the scientific literature. It's all on YouTube. If you want to learn regen farming, go to YouTube. It's really great. You can just sit there going, oh yeah, magic. So there were a number of websites. There are a few associations starting to put themselves together and organisations promoting regen. And so I went and had a look at the barely dozen of them that I could find. And they all kind of listed all the kind of practical things you do on the farm. And so these 4 here are the ones that came up. Everybody said this is part of regen. So the first one is minimising or eliminating tillage, i.e. no-till. Next is avoiding bare soil, keeping it covered by living plants or residues. Increasing plant biodiversity, integrating livestock and cropping. Now, a bunch of my academic scientific colleagues have been having a right old go at regen and going, where's the evidence? Where's the evidence? And they keep shouting. And everybody keeps ignoring them. So, sorry, I'm getting ahead of myself here. There's 3 additional practices that some websites said are part of regen and others aren't. So first one, maintain living plants and their roots year-round. Increasing soil fertility through biological means and the use of compost. I can smell organics there. So we're going to have a look at each of these in turn. And so my scientific colleagues are saying, where is the evidence for these? Well, I'm going to show you there's a lot of evidence in virtually every single one of these practices. So min and no-till came out of the Dust Bowls in the United States in the 1920s. That's another century number, isn't it? So they started developing reduced tillage systems, and then a guy called John Baker in New Zealand went the whole hog and said, how do we get seeds in the ground without any kind of tillage whatsoever? And potentially through some massive corn residue as well, inches of corn residue. And the whole point of this was to negate the negative impacts of tillage. This is particularly relevant in those dry grassland type ecosystems that don't have much rain and on old soils. So you think the American Midwest, you think Australia. Here, Northern Europe, fresh soils, newly minted by glaciers, tillage we can get away with. But you certainly can't in places like Oz and the Midlands and the Midwest in the States. So this is from John Baker. This is what's called the No-Till Bible. And he's not shy about singing his own praises. No farming technique yet devised by humankind has been anywhere near as effective as no-tillage at halting soil erosion and making food production truly sustainable. You can almost hear the Bible being thumped. So they're really keen on this. What's going on here is this book's actually published by the FAO, the Food and Agriculture Organization of the UN. This is agriculture's global headquarters. They're into this boots and all. So no-till was devised by scientists. Baker spent 20 years developing the cross-slot no-till drill. So there is a huge amount of evidence of the benefits of reduced tillage and no-tillage. Vast libraries of the stuff. The next technique is avoiding bare soil, keeping the soil covered. To those in the trade, this is known as conservation agriculture. This is a definition from the FAO. Again, for you guys at the back, I'll read this out. Conservation agriculture is a farming system that promotes minimum soil disturbance, i.e. no tillage, maintenance of a permanent soil cover, and diversification of plant species. It enhances biodiversity and natural biological processes above and below the ground surface, which contribute to increased water and nutrient use efficiency and improved and sustained crop production. That's a hell of a gobful, isn't it? So there's 3 key things to conservation agriculture. Minimising soil disturbance, so that's min-till or no-till. So min-till and no-till and conservation agriculture are completely locked together. You can't really do one without the other. You've got this permanent soil cover, so you either have to have living plants or some form of residue. If you have less than 25% residue, and you can see 25% of the soil surface, you've failed your conservation ag exam. And the species diversification, so not just growing monocultures all the time, or at least having a bit of a rotation. And again, a lot of this is driven out of the American, the massive American fields growing just maize or just soya, that kind of stuff. Regen guys have got an interesting term here, soil armour. They say for this permanent soil cover. If you look in temperate ecosystems, well, basically anything that's not a desert or tundra, the soil is always covered by plants. And so they're saying we really need to mimic natural systems. We need to make sure the soil is covered, the soil is protected by an armour of living plants or plant residues. Right, integrating livestock and cropping. Generally referred to as mixed farming rotations. If you're not familiar with these, ask your grandparents. This stuff has been around since the dawn of agriculture. The Romans knew about this stuff. So we have libraries full of information about the benefits of rotations. And indeed, when I deal with some of the horticulturalists, particularly the guys up in Pukekohe who just love growing onions year after year after year, and they want to know why they've got so many diseases in their crops, so I'm kind of going, I might be able to spot your problem here. So the problem with rotations is they're really, really good, except you can't grow onions every year. You have to grow something else that's not worth quite as much. But after a while, if you just keep growing one crop, and it's susceptible in particular to soil-borne diseases, your farm system will fall over. It's as simple as that. We have so many case studies of that. What's going on in terms of this rotations, nitrogen fertilisers and pesticides are a direct substitute for rotations because they allow you to get nitrogen into the system that you would normally get through a rotation, and they allow you to control the pests and diseases you get when you don't rotate crops. And that's why if you look at organics, rotations are really important in organics because they ban nitrogen fertiliser and pesticide. You cannot do organics without rotating stuff, at least in the cropping sphere. Increasing soil biology, fertility biologically. Fertility is a really slippery term. I really avoid using it because it can mean so many different things to so many people. The first is a soil type. Has it got naturally good nutrient holding capacity? People will describe that as a fertile soil. The other one is, what's the amount of plant available nutrients? Have you got all your nutrients at optimum levels? It's fertile. The other one is soil health. Is it a nice, healthy, fertile soil? So it's kind of a really meaningless term because it can mean so much stuff. But what we do know, and increasingly know through the ecological studies, is virtually all the plant available nutrients in the soil are being delivered through biological processes. Organic matter is dead, living stuff, and as that's decomposed, the nutrients in it are released into the soil. The main store of nitrogen in the soil is as soil organic matter. So the whole plant nutrient system is mediated by soil biology. And we've got lots of really good studies showing if you increase soil biology, you will increase the available nutrients. And so there's that compost thing, which I'm almost certain came off Rodale. So it just smells of organics. The reason we have so much interest in organics about compost is because Sir Albert Howard, who promoted it strongly, he was one of the founders of organics, he really pushed it. Compost is clearly beneficial, particularly if your soil is a bit run down, but I think its benefits have been wildly overstated in many cases. It will not solve all ills by any means. So I'm now kind of coming to the stuff that's a bit more interesting. So all this previous stuff, we've got reams of scientific evidence showing its validity. So this living plants all year round thing, this is kind of conservation ag on steroids. They said permanent soil cover, either living plants or residues. For the hardcore, this plant residues simply don't cut it. They want living plants year round. And this is because plants are the fundamental drivers of soil biology. Plants are what are known as autotrophs. They harvest the sunlight just through photosynthesis. Nothing clever, different, funny. Just plain photosynthesis. They're the only things that capture energy from the sun. They turn it then, they take carbon dioxide and water and put them together, and then from that form a whole load of complicated chemistry. All our carbohydrates, all our proteins, all our oils, lipids, fats, etc. They're fundamentally first made by plants, literally out of sunlight, carbon dioxide and water. Genius. And so they are providing that energy source for all the biology in the soil. So if they're absent for half the year, the soil's going, no energy input, nothing to do here. So the hardcore guys are kind of going, yeah, we want this plants powering our soil all year round. So, and again, kind of coming back to the previous point, in most ecosystems, there is no bare soil. There's always living plants. There might be a big chunk of residue on it. If you go into a forest, there's a whole load of detritus layer as well, but there's always living plants there. Right, so that was the really kind of pretty mainstream stuff. This last one's a tad more interesting, and this is this increasing plant biodiversity. So, going back to intensive agriculture and yield maximisation. The mantra of that was you need to grow a monoculture. If you want to maximise yield, you have to grow a monoculture, because if you get all the different species you want to grow them as monocultures, you'll find one yields the most. So obviously you want to grow that, because if you mix your highest yielding plant with one of those other plants that yields less, the yield's going to be the arithmetic mean, the average. Pretty obvious. And completely wrong. It's quite astonishing. That's been the mantra, one of the absolute kind of founding laws of intensive agriculture, and it's completely and plainly wrong. Because it fails to take into account symbiosis. The fact that living things can not only compete, but they can benefit from each other's existence. In a monoculture, all the plants are identical, so they're all trying to compete for the same air space, ground space, the same nutrients, through the same kind of root systems. If you've got different plants, they take up different bits of airspace and different bits of soil and want different nutrients. So they can exist in the same space and compete less. So this is a classic sum is greater, the sum is greater than the parts. And what's going on here is the agriculturalists are not reading the ecological literature. There's this massive divide between particularly the intensive agriculture scientists and the ecologists. There might as well be a chasm between the two of them. So there's two wonderful terms used to describe the impact on yield of having mixtures. The first is called over-yielding. So that's where the mixture yields more than the mathematical average of the components. Does that make sense? You grow the components as monocultures, get their yield, find out what the average mathematical average is, mix them up, grow them, and the yield will be more than the mathematical average. And the kind of agricultural scientists look at this and go, ooh, that's interesting. Then you tell them about transgressive over-yielding. The name just says it all. It's transgressive. It's heretical. Because what's going here is the mixture yields more than the yield of the best monoculture. It's like magic. This isn't unusual. This is really common. There was a massive study done in Europe using pasture. Multiple countries, multiple years, they found transgressive over-yielding was the norm. If it didn't transgressively overyield, it just plain over-yielded. Nothing yielded like the arithmetic mean. Now, this is really interesting. This is the Jena experiment. They've got a website with a nice little video that explains it. It's in Germany, which kind of explains why there's 10 hectares, 600 plots, 15 years, 100 scientists, and Christ knows how many hangers-on. This is just enormous. And this is an ecological experiment. So they're using a traditional European meadow as a model ecosystem to try and understand a whole load of ecology, nerdy ecology stuff that everybody's arguing about in the ecology department. The great thing for agriculture, it's pasture. So we can look at this and kind of go, great, let's go and see what these guys have found. So what they're doing is they've got 60 different species of plants, and they're planting all of them in everything from monoculture to a 60-way mixture. We couldn't put a 60-way pasture together, 60 species pasture together in New Zealand. We don't have the species here. What they actually do is do some tricky stats. They have 1, 2, 3, 4, up to 16 species, and then they do a big jump up to 60, because it'd be really complicated, but basically every single possible combination of that mixture is out there. Yeah, it's just astonishing. Just truly astonishing. So you want to go and have a look at the video, because it's a hell of a lot lighter reading than their summary paper. So after 15 years, they've been churning out, this is German academics, they're churning out, hundreds of papers a year. And so they wrote a summary paper, it's 70 pages long. It's astonishing. Just truly phenomenal. But what they did is, I can summarise their summary paper really easily. So basically the results they found were, as you increase diversity, everything got better. Basically all the ecosystem services, and they're looking at this through an ecosystem services lens. So as you increase biodiversity, and literally, if you've got 59 species and stick another one in, they could measure the difference. Just stunning. So yield went up, both above and below ground. Invertebrates and vertebrate populations increase. Diversity increases. You get improved nutrient cycling, increased soil carbon. They were also testing drought. They had little rain shelters. Improved performance under drought by having more in your mixture. They had a flood. They built it on a floodplain. I'm kind of surprised, guys. You might have taken that into the planning, but hey-ho, it flooded for quite a long time. And I thought, oh dear, they said something probably in German that's unpronounceable and unrepeatable. But as the flood subsided, they said, oh, we better make the most of this. And they said, we'll monitor to see which plots recover the fastest and the best, the higher diversity plots. There's more better water use, soil health, reduced weeds. You get less weeds, pests and diseases the more species you have in your pasture. Genius. So there are links there. That paper, if you're really a glutton for punishment, you can download that paper because it's open access, it's free. This is another study. So I picked the Jena experiment because it's massive. It's completely comprehensive. It's the biggest ecology experiment in the world. So you really can't start arguing too strongly against that amount of data. This is interesting. This is a meta-meta study. So, deep breath. A meta study is where some nerdy stats kind of scientist goes and finds a number of original research articles on a topic, like does increasing biodiversity have a benefit on farm? And he'll go and find hundreds of those studies and then get all the data from them and then combine them again into some massive, great kind of combined single result. Then there's this thing called a meta-meta study, which I'd never heard of until I found this paper. So what happens is an even more nerdy scientist, statistical kind of person gets a whole bunch of those first-level meta-studies and reanalyzes them again. Just astonishing. Now, apparently this is really common in the medical literature because there's billions of medical scientists worldwide churning out huge quantities of data that nobody ever reads, unlike ag scientists where we're a bit thin on the ground. So this apparently is the first one ever done. But the fact that this is a second-order meta-study means there is a huge amount of data feeding into this thing. This is an absolute solid result. What they found is agricultural diversification, increasing the number of plant species, promotes multiple ecosystem services. So ecosystem services, basically the framework all this stuff is looked at through, without compromising yield. That's actually, if I had been editing this paper, I would have slapped them down. When you look at the data, yield goes up in most cases. So in something like 70 cases, there's either a neutral change or a benefit. 70, I think it's 80 actually. I think it's about 12% of the cases they say negative outcomes of increasing diversity. And those benefits include yield. So it really should say benefits multiple ecosystem services, including yield. So the evidence base out there from the ecology literature about the benefits of increasing biodiversity on farm is really, really solid. The problem is the agricultural scientists don't read ecology literature. They don't know about this stuff. And so they keep going, oh, you can't diversify stuff, that'll be terrible for yield. Well, wrong. And the problem is we now need to farm for all ecosystem services. The best way you can do that is by increasing diversity. And diversity, plant diversity, is one of the big drivers of regen. So, I was part of a project that nearly killed its lead author, Gwen Grillet, here at Landcare, because we started doing this and then COVID came along and we realised we'd bitten off far more than we could chew. But we have produced this report, this initial white paper, and we're in the process of getting all the underpinning papers published shortly. So we actually went and did some research and looked at regen in New Zealand. And again, you can go and download this paper for free. And this was the cartoon we used for opening the paper. So, COVID, recession, climate change, biodiversity collapse. So we kind of weren't mincing which direction we were coming from in terms of this report. So there's a whole bunch of lessons we can take away from this and stuff we learned. One I'd like to kind of just jam in here is the fact that regen is really outcomes focused. And I make the comparison with organics, which is at a practical level on the farm really inputs focused. It does want to achieve things, so it does want to achieve outcomes, but on the farm you kind of go, I've got a whole load of weeds in my wheat. What can I do? And you get out the organic rule book, the standards, and I can't use that, I can't use that, can't use that either. There's just a whole bunch of rules saying what you can't do. The regen stuff is they're kind of going, we want to increase soil organic matter, we want to increase soil health, we want to increase stock health, we want to reduce our input costs, we want to have a better farming life. So they're really focused around the outcomes, and how you achieve the outcome isn't so important. There's kind of things that are really positively looked upon and some stuff that's kind of frowned upon, but you can still use the frowned upon stuff if you kind of are struggling to find anything else that will do the job. Whereas in organics, you kind of go, man, it'd be so useful to use some Roundup here, and you're just kind of going, oh crap. So another thing here is this complicated weed diagram. I'm not going to go into this. First is it's an integrated circular system. Farming is a systems base. Anybody who's done any farming, if you don't think in systems terms, you're stuffed. The farmer is clearly part of this. They're inside the circle. You're thinking about how all these systems work, stuff like the nitrogen cycle, the carbon cycle, all the rest of it. So you're very much thinking systems. Profits very much in here. The marketing stuff is in there. There's a lot of chatter in regen about how do we start making money out of this? And then it all goes quiet again because nobody's quite figured that out yet. What else is going on here? Yeah, and these farmer learning and support networks. We can touch at this on the end. Social media has made a revolution in this space. So we surveyed a whole load of regen farmers and kind of associated industry people and hangers-on and whatnot, and had some conversations with them. This is the royal weenie. I'm an agricultural scientist, not a social scientist. The social scientist then went away and read through all these conversations and noted when key terms and stuff were said and counted them all up. And the thing that came up the top, social well-being. I said at the start, this is a social movement. Social well-being came right up the top. I was going, oh yes, and we're towards the bottom kind of stuff. Boom, straight up the top. The next one was soils, which I thought would be right up the top. Integrated circular systems, access to markets, production, productivity and profitability. So they are thinking heavily about how do we make more money? Because a lot of the time there's not a lot of money being made in farming. There's a lot of money being made at the field days, I'll point out. A lot of those guys have really big flash utes, not the farmers. Mindset, so that was Simon Osborne at the start there. Biodiversity's in there, water, mariculture, air and climate change solutions, regen definition and evidence, because people are still arguing about what it is and what it isn't and all the rest of it. Food quality and safety, animal welfare I thought would be actually far higher. Resilience I was really thinking would be far higher, because that's a big part of that biodiversity. Increase the diversity of your farm, you become much more resilient to things such as climate shocks like drought and floods. And farm integration in the landscape kind of ticked out there at the bottom. This is another thing we pulled out. Complex adaptive circular systems. This is actually really nerdy science, but this is what a farm is. And then there's these mindset and attitude things, context-specific decisions, farm's a living system, question everything, learn together, failure is part of the journey, so it's really kind of, yeah, just try something, if it fails, you're smarter. Open and flexible toolbox, and then this instructional kind of side of stuff. Plan for what you want, start with what you have, maximise photosynthesis, so that's going back to this year-round plant cover stuff. Minimise disturbance, as you know, till in there. Harness diversity, biodiversity. Manage livestock strategically and holistically. And so there's quite a lot of other alternative agricultures. There's holistic grazing management's strong in regen as well. So there's kind of a whole load of stuff from other farming systems being pulled in as well. So I'm going to finish off now and then we can go into questions. I've got another bit of video here from another farmer on his phone out in his field. We had a few rain showers a couple of weeks back. So just, I'll go over what he says. But he opens up, he said, we have a bit of a rain shower here the other day. We had 20 millimetres in 10 minutes.
Hi guys, we had a bit of a rain shower last night. 19.5 millimetres, so 3/4 of an inch, in under 10 minutes. This is ready to drill into vetch once it dries out, and looks good, nothing's moved. This is my neighbour over here, who's extremely proud of his min-chill system, and his min-chill system allows him to quickly and efficiently plant a 600 hectare harvest in the autumn. And 400 hectares of that is burnt, and the whole lot is cultivated. So, yeah. But unfortunately, on times like this, it puts Mother Nature under pressure. And it only takes one rainfall event to lose 500 to 1,000 years of soil build-up, or soil the natural processes of the soil. This is quite catastrophic. The only good thing about it is that I've got a lot of the real estate. And of course, nature doesn't give away, when she gives it away, it's always the finer stuff, which has got all the nutrients in it. So I don't know whether I should be happy or sad, but at the moment, I just shake my head in despair. Surely we have outgrown this sort of thing.
To me, it's a large part of it. We should have outgrown this stuff. We know this. We've been talking about this since the Dust Bowls. And to me, this is a large part of regen. This is farmers looking over their fences and kind of going, this stuff's not good enough anymore, guys. Cows up to their guts in mud, not good enough. We have to do better. So this is farmers, regen for me, is farmers putting their hands up and going, yep, okay, we're part of the problem, and we're going to try and be part of the solution here as well. I'll leave it there. Thank you. We'll take questions.
Thank you. I'm going to be a human microphone stand for any questions. So,
or I can just repeat. I can repeat the questions.
Well, I've actually got a question, but I just want to make an observation that years ago I remember seeing in one of the local farming papers a brief article about some experiments done in Britain where they discovered that even with a cereal crop like barley, if you incorporated multiple barley varieties into one paddock, you got improved yields.
Yep.
That really struck me as strange.
It's interesting. So it was, the point was there was a comment, there was some research done some time ago looking at having different cultivars of barley in the same paddock and showing an improvement in yield. The Organic Research Centre in the UK has been doing that stuff as well for the last several decades. Consistent results. Then you actually start mixing different species. So even if it's two closely related species, like a wheat and a barley and an oat, you get improvements again. Then you start mixing even more diverse species. You start putting a bean in with your barley. And everything goes up again. You get less disease, you get less weeds, you get less pests. So literally the irony here is monoculture literally creates many of the problems we are trying to deal with in agriculture, and by simply diversifying and increasing the number of plants in our systems, we can solve a whole bunch of those problems. I'm just working with the horticultural industry. They've got a big 7-year, $21 million project called A Lighter Touch to help them try and reduce their pesticide use. So they're only going to spend $1,000 on a project trying to look at putting an agroecological solution to pest management into perennial crops. And we've got citrus as a model crop. And I've just designed an agroecological system for their citrus orchards. It's basically a mixture of clovers and a few other flowering plants under the trees to fix nitrogen and provide a whole load of benefits for beneficial insects that will control the pests. And we've got a grass sward, multiple species of grass. I think we've got 20-odd species, some legumes, particularly lucerne, some other flowering plants, some marigolds in there, and we're going to put some annual plants in as well, buckwheat and phacelia, and just strip till those down the side of those. That's going to be radically different. And fingers crossed, we're going to see dramatically reduced disease and pests in there. Okay.
I'm not a farmer. If you're wanting to produce a crop of wheat
Yep.
How do you produce, how do you harvest?
This is part of the problem. Monocultures, intensive agriculture, moving to monocultures has facilitated the whole system. You've got one thing in a field, it's easy to harvest, if everything lines up, of course. If you're using pesticides, and particularly herbicides, as soon as you start creating diverse plant communities, your herbicide options are basically stuffed, because all your selectives just won't work, because you put a selective in it, it'll kill something else you put in the mixture. So this stuff's not easy. Part of the challenge is looking at this and going, okay, how can we diversify? So to me, it's all these issues around climate change and biodiversity loss. You know, there's these comments, oh, we can't afford to move to electric vehicles. It's kind of like, if we don't move to electric vehicles, we are in so much doo-doo as a species. It's unbelievable. So to me, the thing is, we have to diversify the system. It's then, right, let's do the research to find out how we do it. First step, put 10, 20, 30 different cultivars of wheat in. Or just start with 2 if you're really scared. Start with 2. This is kind of one of the things with regen ag versus organics, as we were talking about earlier. Organics is a big step. It's a barrier to entry, which is deliberate. To get the price premiums, we have to make it difficult. Regen, you can be a tiny little bit regen. You can just literally kind of go, I'm going to reduce my glyphosate use by half this season. You're in. How easy was that? So part of this is all these little bits and pieces. If you're unsure, you can just try little bits and pieces. Some of the brave guys will just kind of go, I'm going no-till. Buy a cross slot and sell all the cultivation equipment. Brave man. Or an idiot. I'm not quite sure. So it's not easy, this. This is what a lot of the regen stuff is about. It's farmers helping farmers how to do this kind of stuff. Hang on, we got one more. We've got another question in here.
Once you do the harvesting, how do you separate the beans from the wheat, from the oats, from the barley?
That's where, if you're growing something like a bean and a wheat, or a bean and a cereal, that's often quite easy because they're quite big, different sizes. Yeah, you just put them through this seed cleaner. The seed cleaners kind of look at you very unhappily because their system's set up for cleaning one thing and throwing all the other stuff away. So, you know, there's potentially significant infrastructure changes here as well. But if you're growing wheat and barley and oats together, yeah, you'd be really lucky to separate those out. But what you're doing is you're then growing that for animal feed, and you're selling it deliberately as a mixture. Or if you're growing the different cultivars of barley together, you go and talk with the guys doing the malting, and you say, well, this is what I want to do. Can you see how this functions as a malting product? And if you guys have done that, they go, man, this is really good malting barley. We'll take some more of this. Thank you very much. Because that's got a whole load of fungicides not on it. So, of course, it ferments an awful lot better. Yeah, or, you know, all this other stuff. So part of this, and certainly, I mean, going back to your point, when I'm working with FAR and suggesting some of this, you can see the guys working in the seed industry turning pale. Just frightens the bejesus out of them. They kind of go, oh my God, separation distances, no strict rate, oh no, you know, the sky's going to fall on my head. So there's people looking at this and just going, this is really hard. I can't see how to make this work. But I also look at stuff like the no-till. Baker literally spent 20 years working out how to get in a seed in the ground without any form of tillage. And he was just so bloody minded and working in a period where the government basically gave researchers money, so he could just keep going until he figured it out. 20 years of hard slog, and he figured it out. So that's kind of what we need here. There's some seriously hard slog required here, and some serious investment as well.
I'll come back to you now.
I'm looking for practical advice. We did last year kind of regenerative agriculture.
Yep.
And we got some 26 species from Peter Red symbiosis.
Yep.
And the advice that he gave us was that we had to spray. Well, we're organic.
Yeah.
And we had to spray the paddock to kill everything that was in it in order to get those things into it. So we did it.
Yep.
But is there any other way to go about it? Because we don't want... It was successful, it was wonderful.
Yeah.
But, you know, there must be a better way.
So the question is, they're just starting down. They're organic, doing regenerative, put in a massive multi-species pasture mix, but the recommendation from the seed supplier was to spray everything off with Roundup before they put it in, and you're not allowed to use Roundup in organics. To me, this is one of the interesting tensions. We had a field day actually at Simon Osborne's property a couple of years back, if not more, and Tim Chamberlain's. They're just a few kilometres apart. So we went to Simon Osborne, and he's going on all about the beauty of no-till and his system, and he's on really heavy clay. You know, he went out as a boy with a lump hammer, a club hammer, to break up the clods on this farm. Just astonishing how stuffed the soil structure was on this. So he's waxing lyrical about no-till. You can only do no-till with Roundup because you need something that will eliminate all green plants from the field before you start. Then we went over to Tim Chamberlain's, and Tim's doing a lot of cultivation because you can't use Roundup in organics. And if you don't have Roundup, the alternative is tillage. And Tim had rediscovered the plough after a couple of decades of not using it. He went, it's really great, I really like my plough. Man, there was this massive ding-dong between the regen guys and the organic guys, because the regen guys are going, we're not tilling, and the organic guys are going, you're using all those dirty pesticides, and they guys, you're doing all that dirty tilling. So you kind of have this kind of, again, it's kind of this, you know, challenge of how you do some of this stuff. You know, if we lose Roundup through resistance or legislation or whatever, no-till's in deep, deep doo-doo. Because the alternative herbicides, the tank mixes, are some really quite unpleasant chemistry. You don't want to go near it. Roundup is pretty benign. So to me, the answer in your place would have just been get the cultivators out. Make sure it doesn't rain 20 millimetres in 10 minutes, though. You know, there's so many compromises here. Farming is just this massive bundle of compromises. There's no such thing as a perfect farm. You know, everything you do is a bit of a compromise on something. And so you want to keep your organic certification, you simply cultivate and put that 20, 30 species mixture in. You'll get all the benefits, and the bit of damage you do through that cultivation will be more than compensated by the fact that you get all those benefits out of that cover crop. But yeah, some of the regen guys can be as holier than thou as the organic guys as well. So they'll kind of go, you just can't cultivate, so you just kind of go, yeah, whatever, mate.
Yeah, the results
Yeah.
amazing. No question.
Yeah.
Neville, you would say.
I'd just like to take the conversation briefly back to
Yep.
the difficulties of harvesting a crop that's a diverse mix. And I guess the thing is that the people aiming to exploit one part of that crop, say wheat,
Yep.
have to exploit also the characteristics of that plant that make it different from everything else that's grown there.
Yep.
So I could think the first thing is that maybe you could make that the highest plant
Yep.
in the crop that you grow. Or you arrange your spacings. You have
Yep.
rows of widely spaced wheat in between a lot of other things.
Yep. So the comments were here is, again, looking at different ways of trying to allow you to do different cropping together. So grow something like wheat, but grow something small underneath it. You know, maybe some peas or something. The opportunities are almost endless. You don't actually, growing stuff in strips runs into the problem. The benefits from the mixtures are the fact that they're generally intimately mixed,
Yes,
particularly in an arable crop situation. Agroforestry is technically, agroforestry is where you have very widely spaced rows of very low density trees, so maybe 30, 40, 50 metres between a row of trees, and the trees are 5 or 10 metres spaced down the row. So these are really low density. That is a form of intercropping, and we get major benefits, but the fact is one of those species is really big. It's as big as the gap between. So when you go down to annual species, they need to be mixed at that same scale as they are big. But the other thing is you can just kind of go, okay, we won't grow another crop in here, we'll put a whole load of clover underneath the cereal. And then what we'll do is we'll plant some buckwheat and phacelia at very low density. So buckwheat and phacelia, Professor Steve Ratton at Lincoln, he's done all this work in conservation agriculture, finding biological solutions to pests. And he's found that common or garden allicin, buckwheat and phacelia virtually always come out in terms of being the best plant for nectar and pollen resources for beneficial insects to go and control your pests. So you can go into your wheat crop and go, wheat, aphids, problem. Well, we're going to sow phacelia and buckwheat at such a low density. There's one buckwheat plant and one phacelia plant every 10 square metres or 100 square metres. So there's literally a few handfuls of these things in a field. That's all you need to provide insect pollen and nectar for the beneficial insects to take out your aphids. That's biodiversity in there as well. So the list is virtually endless. It's just we need to think up ways of making it happen. And part of the thing as well is kind of going, you want to do that? Your herbicide options are already stuffed. So you just don't use herbicide in that crop because the clover's now taking care of the weeds. So it's part of this whole system redesign thing as well. We've always had this in organics, and there's quite a bit of talk in this in regen. There's what's called input substitution in organics. You can't use herbicides, you get a whole load of weeding machinery. You're doing everything exactly the same, but you're just using machines instead of herbicides. The system redesign is you kind of go, why are we needing to do all this damn weeding in the first place? Oh, we've got all this bare soil that all the annual weeds really like. Well, let's stop having bare soil. Let's put something there so there's nothing for the weeds to come up through. And one of the things even FAR's trying at the moment, which is communal garden overseas, you have a permanent white clover crop, you strip till maize into it. So you'll come through and burn strips of, because maize is nice because it's on nice big fat rows generally, 32 inch. You burn a strip out, come and zone or strip till the maize in. You leave the white clover there and it just grows back because of course it's stolen infrared. So once the maize is up, the clover grows back over. Works a treat. Then you harvest the maize and you're left with white clover. So you don't have great big runoff over winter. And it's all fixing nitrogen. And the nitrogen's being transferred directly from the legumes, from the clover, into the maize via mycorrhizal fungi, which don't survive if you till your ground. So you have to be no-till. So there's a lot of stuff, it's farming, there's a lot of moving pieces here, and a lot of these moving pieces are really different to what everybody's been used to so far. So again, a lot of regen is, the thing that's the most important change is the bit between people's ears. Right, next question.
What would you put to dilute lucerne here?
Sorry, what would I?
What would you put with lucerne?
With lucerne? What are you using it for? Just grazing?
No, I bale it, feed it to my own animals, so I don't buy anything.
I'll be looking to put a grass. It's kind of almost a rule of thumb. If you're mixing species, a grass, which includes cereals, and a legume. That's the first thing to put in there. Then I'll be probably starting to go, can we put a few forbs in there? So maybe start going, maybe let's put in a bit of chicory, maybe a bit of plantain. They were weeds 30 years ago. You know, they're now really high-value pasture species. You know, want another example of change coming through the system. So I'd look at a few things like that. One of the other interesting things in terms of these diversified mixtures is their impact on stock performance and stock health. So there's a guy at Lincoln called Pablo Gregorini, who's a professor of livestock. He's been looking at a whole load of this diversified grazing and stuff, and he's also worked with a guy in the States called Fred Provenza. They've looked at stuff like traditional herding through the Alps and Africa and how they manage stock there, and looking at how they move the stock around depending on the stock's needs. And one of the experiments he did, he's a professor, he doesn't do experiments, his students do experiments, but one of the ones he supervised is what I call the salad bar experiment. So they got 6 species, common pasture species, grasses, legumes and forbs. They mixed all the seed up and grew some as a mixture, and then they grew another lot as a salad bar. So literally they put a monoculture into the drill, drilled a strip up the field, and then drilled another species in the strip. So you basically get 6 strips with a species in each, and then this complete mixture. Then he gets a bunch of sheep, and he divides them up into 3. One of them gets to graze the mixture. The next lot gets to graze the salad bar, this suite of 6 species, but they're only allowed a choice of 2 on any one day. And the other lot get the full salad bar. So they're all the same breed of sheep, they're all randomised up. The stuff on the mixture is the baseline. The stuff that has the 2-option salad bar yield have about 10% increase in growth rate over the mixture. The stuff on the full salad bar had another 10+% increase in growth again. So from the mixture to the full salad bar, about a 20+% increase in growth. Because herbivores in the wild will eat 200-300 different species of plants, and we give them ryegrass and white clover. Ice cream and salmon are both really, really tasty. How long before you will get sick if you only had salmon and ice cream to eat? And I tell you what, ryegrass tastes really crap. It's really horrible. It's designed not to be eaten. give the least away. So these multi-species mixtures, the impact on animals' health and performance can be really quite profound. And they're yielding more. And they're building your soil biodiversity up and your soil health and increasing your soil carbon and your soil water holding capacity. It's kind of like, yeah, you really just want to figure out how you do it and start simple. You know, put 2 or 3 things in. If that's working, put more in. But you'll probably find the stock will be even happier on the mixture than they will the pure lucerne.
Sue, did you have a question?
Yes, I did. I just wondered when you set up a biodiverse pasture, getting it established, like you said, you have to either, you were saying you till it or spray it out. But what happens when you suddenly get 8 weeks of no rain?
Yeah. I mean,
and so you've got some stock and suddenly...
I mean, that's kind of just part of farming. It's kind of like, it didn't matter really whether it was a diverse pasture or just ryegrass and white clover. If it didn't rain, you're a bit buggered.
Yes.
You know, so, I mean, that's part of the thing. I mean, part of the thing as well, as you start changing your systems and you start improving your soil health, the organic matter's going up, the water holding capacity and all the rest of it's improving, you then actually have more soil moisture, so you have more potential to get something germinated when it's dry. But, you know, if it's really dry, reseeding is probably not the thing to be doing. You know, you're kind of just hanging on in there. You know, some of the regen guys this season were drilling stuff into bone dry ground and just praying for rain. You know, and when it came, stuff germinated. Okay.
Any more questions?
If your primary crop is a perennial,
Yep.
like a grapevine or a tree, nuts, for example,
Yep.
you can't rotate them.
No.
So I'm curious to know, are the benefits of rotation independent of the benefits of biodiversity?
That is a yep.
And if they are independent,
Yep.
what are they and how do you make up for your ability to rotate?
Okay, so the question was, perennial crop, you can't rotate it. You can increase biodiversity in the orchard or the vineyard or whatever. The question is, does that make up for the lack of rotation? That's a really good question, and I don't think I've seen anybody even look at that.
Because rotation could be seen as just a kind of...
It's diversity in time rather than space.
Biodiversity.
Yeah, it is exactly. If you've got a standard rotation of a series of monocultures, you are creating diversity through time rather than in space. My quick on the very hoof answer is, you look at natural systems, they don't rotate. So you would look at particularly with a perennial crop, you would look and say, I can probably get as good a benefit, if not more, by diversifying and not rotating than you would in an arable system by rotating, particularly if you're rotating just a bunch of monocultures. If you were rotating a whole bunch of really diverse crops, you would probably see a lessening of the difference there. And the question for me is kind of like, okay, you've got an apple orchard. You can put a whole load of other stuff in it, like I described before, clovers under the thing and a multi-species pasture mix down the thing and stitch some annuals in. It's kind of like, it's still an orchard of exactly the same plant, and they're probably all clones as well. And then the thing is, well, do I actually then start, instead of just having a whole orchard of Granny Smiths or Jazz apples or whatever, do I mix different cultivars up? Do I then actually put different species in? Do I put some pears in here as well? Clearly, it buggers up your harvesting plan. Makes your spraying plan a complete nightmare. But hopefully what the aim is with these kind of agroecological systems, you can sell the sprayer. That's kind of almost the help. You probably don't want to, because I know in this system I just designed for the lighter touch program in the citrus orchard, we're going to have to spray BT, Bacillus thuringiensis, to control a citrus flower moth. The caterpillar eats straight into the flowers. It's a bit like codling moth and apples. It's a complete nightmare of a thing. So we will be spraying some biopesticides, but they're very target specific. They only target caterpillars, so they won't hit any of the beneficials. So that's what we're hoping here with this, moving from input substitution to system redesign. We really want to design the pest, diseases and weeds out of the system. That's what we want to do. And if we've been doing this for the last 8 years, we probably would have, instead of working on pesticides, we probably would be there by now. That's somewhat the irony in this.
obviously it depends on your mixes, but these 50C mixes, how long are they lasting?
The Yenna experiment's showing they're surprisingly stable. Certainly, what they were also doing is they created functional groups of grasses, legumes and forbs, and depending on what was in the mixture, some things did better than others. So there's kind of mixtures that are kind of more unstable and they lose a bunch of species out of them and then stabilise, and other mixtures that kind of seem really self-compatible. You know, so if you had a mixture of a whole load of grasses, probably the wussy ones are going to lose out of the system. If you've got, you know, a good mixture of forbs, legumes and grasses in there, they're much more complementary. And part of the thing is also grazing management. So another part of regen is this holistic grazing, which has come out of Alan Savory's ideas and thinking. And what they're doing is what they call is long residual grazing. So standard New Zealand grazing management, you grow a foot of grass, graze it down to about 5 centimetres and rotate on. So the deferred grazing, the high residual grazing, is they grow a lot more pasture in the first place, which all the standard pasture scientists will say, well, it's all kind of going rank and stuff. And when they graze it, they actually leave about a third. So they're leaving sometimes 10 to 20 centimetres behind, and that's forming residue. But it's also leaf mass that allows the plants to regenerate more quickly. And they also have much higher density of grazing. So they're really taking rotational grazing to the extreme, you know, kind of techno-grazing kind of stuff. You know, they'll put a huge weight of stock onto a really small area, graze it for a really short time, and then everybody's on to the next patch. So some of these guys are doing 4 or 5 shifts a day. The other thing is they're doing this thing called deferred grazing. So the New Zealand version of this is basically you pick a few paddocks, you lock them up in about September, and you just leave them to go really long and go to seed. So these things reseed themselves, so you don't spend a whole load of money down the seed merchant. There's a lot of really tight wads in regen farming. But then you come in and use it essentially as standing baleage. And ag researchers started doing some research on this, and they did some field plots. So they went out to some regen farms, looked at some deferred grazing, did some comparisons with regular grazing next door, and they found it was actually more profitable. But one of the more interesting things for me is back in the lab, they got a whole load of big plastic pipes, about 1.5 meters long. They grew some ryegrass and white clover in them, and then they simulated standard New Zealand grazing in one lot and the deferred grazing in the other lot. The pipes with the standard New Zealand grazing, the roots are about this long. The roots in the deferred grazing are about this long. It was astonishing. It's kind of going, you don't need to do any stats on that. And of course, you're kind of going rooting depth. What's rooting depth give you? Access to water. That's why Derek Moot bangs on about Lucerne, because it can go down 5 metres for water. And you've got ryegrass and white clover going down 1 metre for water. Just astonishing. So there's a lot of really interesting stuff going on in here, and a lot of stuff we're really unpicking still.
Yeah.
That's right.
Yeah. I'm just really interested in your research with the white paper with land care.
Yep.
Because I've read it.
Oh, you have, right.
Impressive and really well done. But, you know, where's that leading to? Because I think pretty much you said, well, there's a lot of regen that's come from other parts of the world, and we need to have some real more New Zealand specific information and some evidence base. So it's like bringing the science, evidence base to get it.
Bloody scientists.
Yeah, a bit more mainstream and supported.
Okay, so where do we go to from here? So the question was around the white paper and kind of where to from here. So as I said before, what's going on is there's about, I think, 15 or 20 individual chapters / reports that underpin the white paper. The white paper is essentially a summary of. So there is a pile more information coming out in terms of the evidence base. in terms of getting the stuff out there, I'll touch on the social media and kind of getting slightly on the older stage now. The regen farmers introduced me to social media. I was kind of gladly avoiding the whole damn plague of stuff. So anyway, they started up. So they formed a group called Farmer Group, and they called themselves Quorum Sense. Anybody heard of quorum sensing? 1, 2. A few, 3, 4, okay. So for the rest of you, quorum sensing came out of the medical research, and what they found is particularly bacteria will live harmlessly in an organism, i.e. an animal typically, because these are medical researchers, i.e. the animals, us. If their population's low, they're all kind of just ticking there, kind of going, anybody out there? Very quiet. We'll just kind of keep our heads down. And then they go out there and they'll say one day, okay, anybody out there? Yep, yep. And there's lots of people going, yep, and they kind of go, bingo, we've got a quorum. And they turn pathogenic. So there's a whole load of diseases that we carry in us all the time, and they don't make us sick. But if something happens and their populations get too high, they will go from living happily to being really nasty. So quorum sensing was named after this. The fact that a farmer's named it after a really quite esoteric part of medical science kind of tells you something about some of the guys involved in this. So they formed this group, Quorum Sense, and then they said, right, we better start talking to each other. So they said, we'll start a WhatsApp group. And so I was on this WhatsApp group from the beginning, and going, WhatsApp, use this, driving me mad. And I suddenly looked at this thing as this stuff's rolling by and there's conversations flying through and there's guys flicking up photos of stock and there's a video, somebody's on the combine, the header at harvest, and they're kind of going, oh yeah, look at the yield meter guys, and all this kind of stuff, and there's voice and there's chats coming through. And I had this epiphany. I went, holy cow, this is a 24/7 field day. It's just absolutely genius, because literally somebody sticks their head up and they say, oh, I had a really good day today, and they share all their good luck stories, and then somebody said, oh my God, the sheep, literally the other day, the sheep opened the cover on the grain silo and got into the barley. What the hell do I do? Pictures of lots of not very happy sheep. Everyone's going in, do this, do that, do the other, and stuff. So literally, you know, going back to my days in organics in the 1990s, and we started up the Canterbury Organic Commercial Growers Group, and I'm there stuffing newsletters in envelopes. 4 times a year, and we have a few field days and that's it. And they're difficult to read. Farmers learn by watching other farmers. They learn by going to field days. They've now got a 20 whatever, all year round constant field day in their pocket. And if they got a problem, they just dial up some help. And it's kind of like, who cares about the science? You know, we can do science and find some stuff out about rooting depths. They're kind of going, I can look at my farm financials, I can look at my stock health, I can look at my vet's bills. I'm going for it.
I might be stating the obvious, but they've got a Facebook page.
Yep.
Which I get every day.
Yeah.
And they're just sharing information, videos. Or I can personally put a problem up, and the next one somebody will say, oh, I did this, I did.
Yep. So that's what's going on. You can join the group. So there's this core group, the Fanaticals, and they're on WhatsApp. And then there's the Facebook group, which is open to much more people, because we've got about 300 people on WhatsApp at the moment. And if we had any more, nobody would get any work done, because we'd all be showing each other's photos of stuff. So the Facebook group's kind of a wider distribution, and this is what this new custom software is aiming to do, to allow a much bigger people to be on the WhatsApp type of system, but without everybody drowning in tractor photos, or sheep photos, or cow photos, or grain photos, or flower photos. This is another great thing. We had this massive competition middle of summer. Who's got the prettiest cover crop? Oh, I've got more sunflowers than you have. Genius. So you've got all these farmers showing off their sunflowers, and you're going, well, that's not a paradigm change. I don't know what is.
Merf, you talk about tillage or herbicide being sort of the only two options for planting season. Where does the direct drill fit in there? Is that...
So there is kind of more stuff coming on. Just something slightly esoteric. There's this thermal weed technique called electrothermal weeding, which is using electricity to kill plants. It's still horrendously bleeding edge technology, but there are 2 companies in Europe now, one called Zasso and the other called Crop.Zone, for some unfathomable reason, both of those have got commercial machines on the market that will be Roundup replacements for essentially blowing out an existing pasture, assuming you grazed it down, kind of reasonably short to start with. So that technology is coming on. But a lot of the time there's other kind of techniques. There's something they now talk about, just trying to think, it's green, I think it's green sowing or green plant, I think it's green planting. So you've got an existing crop or something in, you come in with your no-till unit and you drill into the existing green stuff. And then depending on how long it takes to germinate, you then blow it off with Roundup. So it's kind of part of going all the grazing, the clover and the maize thing. One of your options is to come in and use some strip cultivation machinery. Or the alternative is to do strip Roundup strips. So it's a lot of this thing is guys just kind of going, okay, how do we maintain this green cover even more than we are at the moment? And there's guys trying this. Far tried it with white clover and maize up in the North Island. They used Roundup. They didn't use enough Roundup. The clover got a headache, but it didn't really knock it back enough. So, there's some mistakes being made here. That was part of it. Learn from your mistakes. So, yeah. Look, guys are doing all of that. That was one of the things Tim Chamberlain was doing on his organic North the farm up Amberley. Up Amberley. Amberley's normally that way for me. And he would just stock the bejesus out of it and just get them literally to stamp the stuff into the ground. So there was a blade of nothing left. Sow over it, get the stock to stamp it in, had to be a bit moist, and he would get a complete reseed with no cultivation, no nothing. And another one is undersowing. So typically in your arable crops, you get it established, get it going, and then you broadcast something else underneath, a cover crop or another pasture mixture, that establishes, but by then the cereal's kind of way ahead, and so the undersown stuff is kind of really sulking. But then you take the cereal off the top, let all the light in, take the competition away, boom. So there's a whole plethora of techniques out there, depending on what your system is, that you can do that. So there's potential for getting several crops in a row, including pasture and arable crops, with basically no form of tillage whatsoever. It's just thinking up clever ways of doing it.
Richard, you had a question.
Yeah, hi, my name's Richard Cummin. I'm a rural GP in Waikari, so I've been in the area for 30 years and know lots of farmers and watch things happen. Two people who must really hate you are the fertiliser companies and the pesticide herbicide companies, and so I'm just interested in how they're responding to this. And secondly, talking to friends of mine who are farmers, they said for a long time the teaching of agriculture, I think, was captured by the intensive agriculture model that put on lots of fertiliser and monoculture. Is that changing now? So the young farmers being educated, is that changing?
Okay, let's a whole bunch of questions in there. So one, do the input retailers, all the fertiliser and spray reps wouldn't like regen much, and the next part is what's being taught at Lincoln. So there's this one classic graph that does the endless rounds in the regen space, and it's from Canada, and it's over something like the last 50 years going along here, and one of them is kind of farm income. The other is farm profit. And it does that. And the third line on the graph is the profit, is the amount of money farmers spend on inputs. And the regen guys kind of go, I can see why I'm not making any money. I'm spending all my profit in town. So the comment I made earlier about a whole load of tightwad regen farmers, they're seriously looking at this and kind of going, the economics are completely stuffed here. The farmers are really the people that are not making any money out of farming anymore. And so they're kind of going, well, if I can put in a mixture and I don't need a whole load of herbicides and insecticides, well, there's a saving. And then they're kind of going, well, I can go back to Grandad's white clover. I can get the legumes back in the system. And that's a whole load of fertiliser bill gone out the way. And I've been over-applying phosphate for decades. So will the parents. I just tell the fertiliser rep to go away and just start using up some of that over-applied phosphorus from the last 30 years. And then I'll get my biological system going. And I'll get be able to reclaim more of that phosphorus. And so I've got a lovely little chart on phosphorus and mycorrhizae. If I can pull this top off again. So, another chart. Yields going up here. Applied phosphorus from 0 to about 300. And they had the same thing. It's in pots. They had one plant. Half of the pots were inoculated with mycorrhizae. The other half weren't. So the pots that didn't have mycorrhizae, the growth response curve, as you put more phosphorus on, did this. The plants with the mycorrhizae, their growth response curve looked like that. So even if they put 300 kilos of phosphorus on the pots without mycorrhizae, it still didn't reach the yield of the pots with mycorrhizae. The optimum for phosphorus application for the plants with mycorrhizae was 30. So if you manage to get more mycorrhizae back into your farm system, what's that? There's an awful lot of phosphorus you can get out of the soil before you need to go down to Ravensdown and balance again. So a lot of the guys are looking at this stuff. There's a lot of talk in regen about fungal bacterial ratios. It's probably almost complete codswallop. There's a whole load of Fruit Loopery out in regen land as well. There's really great ideas, and there's some really bonkers ideas as well. But getting mycorrhizae back into your farm system, you can potentially get that kind of response. And the thing mycorrhizae fungi do, they're all tiny little filamentous things. They hate tillage. You smash them up with a whole load of cultivation, it takes them a long time to come back. So the mycorrhizae are certainly good. And again, that example of mycorrhizae directly transferring nitrogen from clovers into maize plants. They did the research. They put radioactive nitrogen onto the clovers, did the measurement on the maize plant. Literally within hours, it had transferred the nitrogen from the clover into the maize. Somebody else did an experiment. They discovered that the mycorrhizae are operating a carbon trading floor. So they can extract phosphorus far more effectively than any plant can. And so they were literally kind of going to all the different plants they're connected to. Okay, got a unit of phosphorus here. How much carbon is somebody going to give me? They gave all the phosphorus to the plant that will give them the most carbon, and literally just turn it off to everybody else. And then the others kind of go, crap, we really need that phosphorus. We'll have to up our carbon offering. Literally just quite phenomenal. So, you know, and if you're running a straight chemical system, you're tilling the crap out of the soil, there's no biology in there, and then you're putting a whole load of ag chem on top, which isn't helping. It's probably not so directly bad, but you're just not getting any of that kind of benefit. You know, and to me, the classic thing, a lot of people in the regen are really worried about the direct toxicity of herbicides and ag chem in general on soil biology. For me, the clearest, biggest impact of ag chem on soil biology is they eliminate weeds. You're eliminating living plants and you're eliminating diversity from the system. And that's soil biology. So some of the weed scientists in Europe are showing that if you actually left more weeds, your yield would go up because you've left naturally occurring biodiversity in place. Clearly, if you let a whole load of fat in and stuff go completely rampant, you're buggered. But, you know, just a whole load of little innocuous weeds on the ground, are they actually harming yield? You know, and this is one of the points I make. I did a load of work with FAR around the herbicide resistance issue and integrated weed management. All of pest management, including weeds, it's an economic decision. Your control, and, you know, just as in organics, getting a hoe out or getting the sprayer out is going to cost you money. You would therefore need to see that money back, or ideally quite a bit more. You want a return on your investment. So if you go and spray something, it costs you $100. You want to get at least $112 more yield out. A lot of the time, you're getting no more yield out. You're just controlling weeds. The Yanks have this great term, recreational tillage. The guys in the Midwest, it's kind of like, man, there's nothing to do today. Let's get the tractor out. Just go do some tilling. And there's almost a certain amount of that. It's kind of like, oh, there's some weeds there, we better kill them. It's kind of like, are you going to make money killing those weeds? If not, go down the pub. You know, make some better use of your time. You know, you probably make more money by going down the pub than spraying those damn weeds.
With this sort of methodology, I would think that farmers would have hope and less cost. They must knock on the head this horrible suicide rate we have.
Yeah, I mean, that's the big thing, the fact that social thing came out so strongly up the top. And one of the kind of catchphrases is, Regen put the fun back into farming. You know, there's guys on the group kind of going, I was bored, you know. I kind of figured out the system and we were kind of just doing the same stuff every year. They said, this is really exciting. I can get lots of crazy new stuff and make lots of mistakes and learn lots of, you know, fun new things. So yeah, look, I mean, it's for a lot of these guys, this is a major revolution in terms of, you know, there's this massive social network now. So instead of just having a handful of their neighbours they can talk to over the fence and down at the pub and down at the social event, and down at the hall and whatever, there's now 300 guys on their phone. You know, so the support is phenomenal. So yeah, I didn't actually answer the other half of this question here. What's happening teaching? There's interesting pockets of stuff going on. Steve Ratton, who was my supervisor and a great colleague as well, as an ecologist, he just moaned like you wouldn't believe about the ag scientists. You know, he says, I'm doing all this groundbreaking stuff around conservation, biocontrol and controlling pests without chemicals. And the students in the ag department don't even know he exists. So, you know, I mean, academia has been ridiculed since the dawn of time about the fact everybody's in silos. And certainly the current funding system makes that position much worse. You know, scientists don't talk to each other because they feel they steal each other's ideas and get their funding. There was a great joke in New Scientist just last week on exactly that. And I know cases of Lincoln of people stealing, you know, somebody else has popped up and said, oh yeah, I've got this really great idea. I think we should look at X, Y, and Z. And somebody's kind of listening in. And 6 months later, this other person's got a great big funding grant on X, Y, and Z. And it wasn't their idea. So literally there's, you know, scientists going around stealing each other's ideas. So if we weren't competing and the funding system said you actually have to cooperate and collaborate with each other, we'd probably see a really quite different education system as well. So yeah, the education system at the moment is a major problem. And again, if you want a further example of that, a number of scientists led by John Hickford, Professor John Hickford. There's the New Zealand Institute of Agricultural and Horticultural Scientists. They've got a monthly magazine style newsletter thing called Ag Science, and they dedicated a whole issue to slagging off Regen. The academic quality was so poor it was embarrassing. They just had completely in. One of them said, oh, Regen's like organics, and slagged off Regen on the basis that it's like organics. It's nothing like organics. So I would have failed them if it had been a 100-level essay. It was that bad and that appalling and that embarrassing. Okay, before I really get wound up.
You've just about answered my question. I was going to ask you why scientists like Jan Wright and Jackie Rexworthy, is it, from So Against Regen.
Yeah, look at. I'd really like to get some psychologists and social scientists out there to find out what the hell's going on. I don't know. I'm kind of making guesses and assumptions here. One of the things, in a true paradigm shift in science, the change is so great that there is literally no communication between the old world and the new world. You know, you use the classic one of going from Newtonian physics to quantum physics. Man, quantum physics is completely crazy. You know, it's completely right as far as we can tell from every experiment we've done. And to me, there's quite a lot of that going on in the ag science. So I said before, a whole lot of the ag scientists don't read ecology literature. Pablo Gregorini, who I mentioned earlier, had a workshop. He's got hold of the dry half of Ashley Dean and is looking to turn it into an agroecological system. And so he had this workshop. Oh, and I always forget this guy's name. He was Derek Moot's supervisor. He introduced Derek Luke to Lucerne. Anyway, he's been retired 15 plus years, but he was in on this workshop. And there's a whole bunch of us jabbering on away about agroecology, this and that and the other. And he's kind of looking really puzzled. He eventually puts his hand up and he says, "What's agroecology?" And there's a bunch of us just kind of looking at each other and blinking and going, did he just say, what's agroecology? Agroecology as a science started in the 1920s. It's a massive social movement in South America. There's this guy who spent his entire life at Lincoln, plus 15 years of retirement, and he's still working, doing stuff. Dick Lucas is his name, and he's never heard of agroecology. I heard of agroecology when I was at school. You know, so there is literally this massive chasm and this complete lack of communication. And one of the other things I think is there's a feeling, possibly a feeling of being threatened by some of this stuff. You know, the problem with being an academic, you spend your whole life working on something, you know, and really becoming the world's expert on this, and somebody else comes along and shows your entire life work's been a complete waste of time. You're really, generally as a human being, not terribly excited by this turn of events. Especially when you were hoping for a big glorious retirement. So, you know, there's a lot of old dog, new dog stuff going on here. Probably a lot of grumpiness, the fact that it's farmers doing it by themselves instead of the researchers telling them how to do it. You know, there's probably a whole bunch of stuff mixed up in here. And somebody said on Quorum Sense the other day, I wonder who's paying Jacqueline nowadays. You know, so all kinds of slanderous, you know, kind of stuff being going, you know, who's in whose pocket.
She's on the board of some balance or something.
Yeah, look, I mean, I don't know what her position is. Frankly, I can't even be bothered reading and listening to Jacqueline Roworth, you know, and Doug Edmeades and people like that. They're so stuck in the yield maximisation mentality that they just can't get their heads around that there is a different way of doing stuff. Yeah, I'll leave it just there as I've got another anecdote. Let's have another question.
Okay, you talked about cropping mainly.
Yep.
Do you have a crossover into animals?
Yeah, so the regen stuff is very strongly, I'm a cropping guy. I started out in vegetables. The most evil cropping system on the planet. Vegetables cultivate the crap out of everything, grow really low-yielding, watery crops that do nothing for the soil. So the regen came out of the mixed farming systems in the States. So the animals are really integral to the regen. That's just my bias. Because I think about farming and I think of nice rows of crops everywhere. Happy rows of crops. I hate gates. Can't stand livestock. You have to keep shutting bloody gates all the time. Terrible things. So that's just my internal bias. You know, the guys are really looking at integrating the stock, and going back to the question over here about how do you turn stuff around. You know, Simon Osborne is really strategically using stock. You know, he'll go in and sow a cereal crop into just a whole, literally bunch of weeds, just a whole load of carpet of stuff. And the cereal's quick growing and it comes up. What he does is he goes and puts a whole load of lambs in there in spring and he nails it to the board. Cropping weeds are virtually all really palatable. That's why they're cropping weeds, because if you put them in pasture, the stock eat them. And they can't survive being eaten either because they've got their growing points up in the air. So he will strategically use stock as part of his system. He's actually a cropping farmer. He gets the stock in. He doesn't do the stock himself. So he's integrated in. And this was one of the points Alison Stewart down at Farm Aid, she said, you know, in terms of the arable farms going forward, she was saying, you're going to have to return to mixed farming. Alison's really great because she's come out of science. Because a lot of the levy payer organisations, all the people involved, they're all ex-farmers and they'd all die in a ditch for their industry. Alison's great. she's beholden to no one. And if she thinks somebody's doing something stupid, she just tells them really greatly. So she said, yeah, you're going to have to diversify. In fact, if you want one word to explain how we're going to have to change our farming systems, it's diversification. You know, there's a lot of talk about, all these livestock, you know, breathing methane everywhere and climate change and all the rest of it. And we need to have lots more plants grow. If you want to find a really good way to knacker your soil, grow lots of plants without having a rotation with livestock and pasture in them. You know, there could be nothing worse than increasing the intensity of arable and vegetable production. So yeah, the livestock are absolutely critical. And part of it is looking at how you change the system to improve livestock performance. You know, and I certainly know of organic farmers that spend, in dairy, organic dairy, they spend $10 a year per head on vet bills. You know, there's guys in the conventional industry pushing everything to the max. They're spending $1,000 per head on vet bills. Ouch. You know, you have to look at your system when you're doing that and kind of go, is this the smartest way to make money? Okay.
Are we ready to break, or are there any more questions? Thank you all for turning out on such a miserable evening. Nami, and thank you, Merf, for attracting all these people out.
I hope it was me.
Questions. I'm pretty sure it was. As usual, we have some
goodies.
Some goodies for our speaker. There's a bottle of wine. There's an aki.
Oh, very nice.
There's a cake.
Oh, right. Wow, cake as well. So, I'm doing very well. Great, thank you very much.
Thanks,
right,
everyone.
very good. Well, thank you all very much. I am going to head off because I've got to get back down to Christchurch now, so all the best. Enjoy the rest of your night.